Is Codeforces. Okay, so now we are doing Codeforces contest 853 Div2 problem number A, right? T number of test cases and number of length of the array, and then containing n elements an array, and then you have to return yes or no. Yes, if it is possible to reorder the element to make the array beautiful, otherwise no. What is beautiful? So array is considered to be a good if the GCD of the elements in A is no more than its length. So GCD of element, all the elements we can find out in just over time, and then just check it whether it's greater than its length or not. If it is greater than its length, sounds good. If it is lesser than its length, is good, right? If no more than its length, okay. So if it is just lesser than or equal to its length, it's fine, right? And what is beautiful? Beautiful is basically, we are doing this thing for every prefix of A. So array of at least two positive integers is beautiful if its prefix of length no less than 2 are good. So basically prefix of length greater than equal to 2. 2 and greater than 2. So that's what you have to do for every array. You have to check its prefixes without sorting. The sorting is not being applied over here, I think. Oh, no. Sorting is applied. Okay, like you can sort, but that's not about sorting because you can reorder the elements. Okay, so you can reorder elements in any way which you want. So you got the question? What it is? Array you have been given array, and then you can reorder the elements of this array such that what you want in the end, that every prefix of the array of length greater than or equal to 2 should be good. Should be good, then the array will be called beautiful, and then you have to return yes. So how it can be good, how the prefix can be good? Prefix can be good if the prefix length and prefix GCD should be greater than prefix length. Okay, lesser than prefix length, or equal to also works, right? Now in this case, GCD of a length. Okay, so basically you can reorder it as either 6 comma 3 or keep it like this 3 comma 6. These are the two possible reorderings, right? Now the answer for this one is not beautiful, and answer for this one is also not beautiful. Why? Because you'll check prefix of length 2 for this, right? 2 and greater than 2. So prefix of length 2 has a GCD equal to 3. So that's why it's greater than 2. It's not good, right? And because it should be lesser than or equal to 3. Sorry, it should be lesser than or equal to 2. So now just let me move towards the logic before telling all the cases. So let's take a bigger case and then we will see this. So now there are possible reorderings and factorial reorderings we know, but which reordering will be good to us? GCD has a property. Then let's say up to this point you have GCD equal to G. Now if you take GCD of this number G to any other number, the GCD is always going to reduce. So currently let's say it is G1 at this point. After taking it with some other point, it's G2 at this point, and then it's G3 at this point. Okay, and yeah, let's do this only. So first number you consider this as G1, or you can say first two numbers GCD equal to G1, then third number GCD, and then all these three numbers GCD equal to G2, and then all these four numbers GCD equal to G3, which four number represented by four dashes, right? Now you can easily say that G1 is greater than G2 is greater than and G3, right? It can be equal, okay, equal to or greater than something like that, but it's always going to be same or reduced. So we are just checking the condition for this one. If this is fine, which means this should be, so G1 is the maximum of all, but I want G2 G1, my constraint is most high at the G1 because I want my G1 to be greater than, not greater, lesser than or equal to 2. I cannot have it equal to 3. Yeah, I cannot have it equal to 3 because it was giving out false, right? So the length is till this point the length is just 2, and I want the GCD to be lesser than its length, so I want GCD should be less than 2. And over here we know that G2 and G3 is obviously lesser than G1. So if G1 is less than 2, G2 and G3 is obviously less than 2. So the whole thing comes to just first point is to put two elements in the first, reorder elements to put two elements in the first such that their GCD should be lesser than or equal to 2. That's all about it. So in this case 10 comma 14 serves the point of for us. Then GCD is just 2, and that's fine for this array of length 2, prefix of length 2. After this, we know that GCD is going to be lesser than or equal to 2, so it should be obviously satisfying. So you have 35, still the GCD becomes like 2 and 35, GCD is just 1. And then again, GCD is just 1 because, yeah, you know why I'm saying GCD of complete prefix, GCD of complete this is 1. Why? Because 35 does not have 2, but 10 has 2. So yeah, you know what I'm saying, right? So GCD of this complete is 1, and but up till this point it was 2. So yeah, that was satisfying my criteria, so it's fine. So the question boils down to the logic that, just see, uh, just put two element in first two position such that GCD of them is lesser than 2 or equal to 2. So this will do, like how I'll do, I'll just calculate the minimum GCD of every possible pair, because I just want two elements GCD, so I'll check all possible pairs. Okay, so this logic actually, yeah, it comes from within and it comes from being a first question, and yeah, we can do this, everyone can do this. But the thing about this is, mn is equal to, let's first do this, then I'll say. But this is some similar idea which we did in some previous questions also. Let me just show you. Not exactly, but yeah, previous question of this day only. So vector, not vector, just I'll say, hmm, we have been given int n, c in n, vector of int an, a of I, yeah, and I forgot the number of test cases for sure. Now what? Yeah, that's all. This was your n. This was your array. You have to see mn. Initialize with the 1e8, 1e9, whatever. Gives you the minimum of all. It should, yeah, you can do it like this. You can do it like I plus 1 to be making more sense. Yeah. Uh, but yeah, the answer doesn't get changed for that. So if your mn is less than equal to 2, you are fine to go, right? If your first prefix satisfies, everyone will satisfy because everyone will have GCD lesser than 2 or equal. Yeah, something like that. Abbe, oh, what's issue in this? Yes, no. Vector slash dc++ dot h. Okay, comments should be commented. Sum this up. Double no, yes, double no. I think it's fine. Let's see, or it should be fine because the logic is that you have to find the minimum GCD and then you have to see that accepted. Okay, let's move to the problem number B. Let's move from here. So in this, you have been given t number of test cases, a number n and string of length n. You have just to return yes or no whether the string is a palindrome after performing the inversion magic just once, exactly once. It's not like at most, yeah, exactly you once you have to do it and just once, and print no otherwise. And then what is inversion magic? You have been given as a string. You want to make it palindrome. You can do the operation. Operation is you can select a segment L to R obviously, and then you can flip this to 1 to 0, 0 to 1, and then if that becomes palindrome, then it's fine because you can just apply only one inversion, right? And if it's palindrome, then we will say yeah, it's palindrome. Yeah, otherwise no. That's about it. The operation is just selecting a segment L to R and then flipping that segment 0 to 1, 1 to 0, and then checking whether it's a palindrome or not. If it isn't palindrome, if it becomes, then it's fine. But the only thing becomes how to choose wisely that segment, right? So let's see, it would be, I think, more simpler than first, but yeah, but slightly implementation, yeah. So currently it's already a palindrome, but you have to still apply one operation. So what is the best thing to do is to apply operation on the complete string. So it will make it 0 1 1 0. That's again a palindrome. But in this case, it's not a palindrome. So where you should apply the uh, hmm, so the thing is, divide this into like yeah, half parts. And if there is a middle element, just keep it as it is because it doesn't matter like whether you flip it or not. But yeah, but the main thing is that your first part should be equal to your second part in the reverse order, not just exactly equal like it is in this case. It should be reverse of the second part, so it becomes a palindrome. So now what you need to do, so 1 0, either you make this 1 0 0 1 or you make that 1 0 0 1. Then in both cases it's a palindrome. What was this? This was 0 or this was 1? This was 0. Okay, fine. Now what you can do, you can just say ki whether your first element is equal to your last element or not. If it is not, that I will be doing the work for this one. Okay, fine. And if yeah, you will be going from this to this. Let's say let's just generalize this, and then there is a middle element. It can or cannot be existing, right? If it's not a middle element, so then I will check this. If this thing, let's say this is x and this is again x, then it's fine. Okay, but yeah, if it is c, then these two are not fine, so I'll make it equal to c. Okay, like I will consider this starting point of my like right point of my sub array is this. I'm changing but the back part. Okay, you can change the front part also. I'm changing the back part, right? So that's what we can do. Like also what we can do, key if it is equal. Okay, so let it be equal. If it is not equal, like it was not equal in this case, so you'll say that okay, I'm gonna do the operation on this one. So make it c first of all, and then say that I have started my window. I can now just end it anywhere you want, right? So yeah, now like or this is the ending point of window. I can start from anywhere you want because yeah, this is a like your right window or right point of your window is now being made. Now you just need to select your L segment where you have to start this window from. So that will be, you will be just keeping moving forward, right, 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 right. Like left in this case or right in this case, yeah, whatever. Yeah, this is what is so confusing. It can be done in so many ways. It can be done in so many ways. This problem, yeah, it becomes confusing sometimes. So but yeah, we'll stick to one way only. Now I said this, that we will check first and last element equal or not equal, then just move forward. Don't start your segment. Equal, then move forward. Don't start your segment. If it is not equal at any point, you started your segment and you just say that I started my segment. R is equal to that is fixed. Now you will just see move forward, and if they both elements are equal, now what will happen, you will break it, because that's not good. Because no, you can just select this segment also. Okay, so if it is equal, your L point is also being met. Okay, so you just started and then you just ended at the same point. Okay, at the same point, and now you still check it if some points are equal or not. If now some point comes out to be say that okay, I'm not equal, you will just say no. Otherwise you will just say yes. Otherwise what I mean, like otherwise like let's say this only one point was not good and other points are good, then you will just keep on checking, 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 and coming backwards. You're coming backwards, and yeah, all points are good, fine. But then some point came that okay, I'm not good, so you'll just return false at that moment. Or if you have not started the window, you will start that window, right? So I think that should be the thing, but how I did it was a different way. But yeah, now I want to do this in this way. And the t and n you have been given, and you have been given. Now, the thing is, what I said, n1 is when you are starting with, and n is going to be actually, yeah, greater than by 2, because your middle point just be generalized. So in this case, the length is 5. So your middle point is lying at the index n by 2. So you don't need to see the index 2. You just need to see index 3 and 4, right? So it should be greater than n by 2. N by 2 in this case is 2. So it's greater than n by 2 is fine, right? Hmm. So you don't need to see this index because it's obviously fine, and even if this index doesn't exist, then also it's fine. 0, 1, 2, 3. Okay, so if this is 4, yeah. Now if this is 4, divided by 2 will become 2, and you need to see the second index. I will say that int r is equal to -1. I just made like that. And if your s of I is equal to s of n minus 1 minus I, yeah, it's in this case also, because n minus 1 minus 1 is 0, and then I think it should be fine with it, right? Yeah. If that's equal, then don't do anything. Just continue. Just continue. Just continue. And if they are not equal, otherwise, like if they are not equal, then only you have to do work. Okay. Uh, Now just it's not about continue. Then you need to check. Okay, if it's not equal, then you will start your index. Or you'll say ki, okay, my r is equal to that id. I, right? Okay, that's fine. Now only if r is equal to, now you'll run a while loop. While it's not equal, just move forward, forward, forward. Actually, you're moving backward, backward, backward. Or you can see it like you change the complete half part. Oh, so that's why I'm saying it is so confusing. So let's just be a formal way. We will keep a vector. Okay, we'll keep a vector of int v. Now we'll just see ki int I is equal to 0, I is less than n by 2 only. Because yeah, now I'm seeing from forward. If your s of I is not equal to s of n minus 1 minus I, which we know, then what we'll do, I'll just push back this into my vector. All the elements I'll push back which are not good. Okay. And obviously we will be seeing good or not good in one side only, because we will make it equal to other side if it can be equal to, or otherwise we'll just return false. So now it can be good only if when you have pushed all the index which are not good. Let's say this is the thing. Let's say this is the thing, like this is the thing. Okay, this example we are taking, right? Which example? This example. I'll say whether my first index is equal to second last index or not. It's not. So I'll push 0 into my v vector, and then I'll say that whether these two are equal to or not. They are equal. Okay. So I'll not push 1 into my key. And then the second index comes out to be not equal. So like this 1 is not equal to this 0, which 1 is not equal to this 1 is not equal to this 0. So I'll say that, okay, put this. So now the condition is that this vector has to be continuous. Vector must contain continuous elements, then only like we'll say that this is a complete one window only and one window only. So yeah, that's about it. So if how to check whether I have a vector have continuous elements or not, and I is equal to 0, I is less than not n, just v dot size, and I plus plus. If v of I is not equal to v of I minus 1 plus 1, I will just say that, okay, you're not fine, you're not fine, just see out no, endl. And yeah, don't do anything else. Otherwise, you'll just say C out. Yes. Handle and define your next. That's about it. That's exactly about it. So yeah, I try to be more intuitive, and I know obviously this is a more intuitive question, but this works, putting everything not equal in vector and just seeing that whether the vector is continuous or not. Why it doesn't works? Because it has to be double, and anything else. And okay, yes, no, no, yes, nada. Oh, yes, yes, no. What is this? In this case, what will I push? I'll push first, I'll push second, and that's how it is. Ah, sorry. I should start from 1 because I'm asking from I minus 1, and that otherwise, yeah. It is no, and then submit. Now let's move to third problem in the next video, guys. Bye. But yeah, this is accepted. Let's just show you. Running on the first, running on the second, accepted. Okay, guys, that's about it. We'll lose third in the next.